Welcome back everyone. So we are back with another video. So in today's video we will discuss the topic analog computation. Okay. So let me first give you the brief introduction about the subject itself, and before telling that, let me tell you one thing. So in order to understand this lecture, you have to you should first know about the op amp, that is the and its application, that is op amp as an integrator, inverting amplifier, and inverting summing amplifier. Topics you should know in as a prerequisite. Okay, so let me start the topic with the introduction. So as all of the physics can be explained by basically the differential equation, that too in particular with the second order differential equation. So all the fundamental laws of nature are described by the differential equations. So thus it becomes very important for all of us scientists and engineers to first formulate the problem, that is to take the physical problem and make a mathematical formulation of that problem, and that to solve it. Now the solution of the equation does not we cannot do that manually, so what we do is we use the computers. So let me give an example of formulating a physical problem. Okay, so this is basically a physical problem. You can see there is a rocket and the fuel is getting so the combustion is happening, and it is releasing some fog, you can see. So what is happening here, and it is getting to the upward side. Okay, so basically the force acting here are, one is the thrust, so the thrust will propel the rocket to the upward direction. Let me represent the thrust by T, and the force of the rocket will be downwards, that is the weight that is of the rocket, which is m times the g, and the drag force, that is the, here you can see there is air. Okay, so air will provide a resistance, so the drag force will be also be in the downward direction. Let me represent the drag force by d. Okay, so these are the forces in acting, so you can write the Newton's laws of Newton's equation of motion with this forces. Now focus on the m here. So this is basically a variable mass system, so we cannot take m as a constant. So how to deal with that I will tell you. So first write the Newton's equation of motion, that is thrust is acting upward and weight and drag is acting downwards, so that can be balanced with the mass times acceleration. Now as I told you, this is a variable mass system, so the fuel is being burned at a constant rate, that means the mass is reducing. Now let's say that the rate at which this is happening is q. So what will be the mass at the time t? So if the rate of decrease is q, then at time t the mass will be decreased by an amount q times t. So at any time t the mass will be m naught minus gt. So let me simply replace this value of m in the equation number 1. So replacing the value of m by m naught minus q times t, I got this equation, and also I replaced a by dv by dt. So acceleration can be written as rate of change of velocity. Now experimentally it is seen that the drag force is proportional to the second power of velocity, and if you want to remove this proportionality, you have to introduce a constant k here. Now the k will depend obviously on the air density and the aerodynamics or the geometry of the rocket. Okay, so for d you replaced k times v square, and also you took this term to the RHS and took common, and at the end you got this as this equation. Okay, simple. Okay, so this is very simple. So this is the equation 2. So what we have done here is we have formulated a problem. So this is basically an approximation of the real physical situation. Okay, now how to solve this equation? So as I told you, we will not do it manually, so there are two approaches. The first one is digital computers and the second one is analog computers. Now digital computers, what they do is they use numerical method to solve these types of equation, and the solution to the equation 2, that is this equation, will be obtained as a table of numbers for s. Okay, s that is distance and the time t. Okay, So that's how the digital computer will provide us the solution. But we will take the second approach here, that is the analog computers. What they do is they use a physical model equivalent to the given equation. Let me give an example of this. If you remember in the 12th class you have studied the LCR circuit. So what does that circuit do is that can basically represent the SHM, if you remember. So this is the same type of thing. The model is different, but that can resemble some analogous to the real world problem. So that's what we are doing here. Okay, so and the model will be subjected to inputs analogous to those in the given physical systems. Okay, for instance, let me give the example here. The analog computer can use some voltage, let's say V1, as a thrust, that is T, and for the independent variable distance S and time T, that can use some other voltage, that let's say that V2, V3. Okay, now the answer will be obtained as a continuously varying voltage. Okay, so the answer you will get will be some continuously varying voltage. Okay, and that will give the trajectory. And how can you see the trajectory? In the, you can see the trajectory in the oscilloscope. So oscilloscope is an instrument like this, so you can be recorded. Oscilloscope you have used in your laboratory, I guess. Okay, so I have used it in the lab, you also have used in the lab. Now the analog computer we will study will use the electronic circuit to solve the differential equation. What kind of electronic circuit it will be, I will tell you. Okay, so that's why we are using here electronic differential analyzer. It is termed as electronic differential analyzer, the method we are using. So for example, let's see for example the solution of linear differential equation. A linear differential equation where our a and b are the constants. Okay, and we are provided with the initial conditions. Y at t equals to 0 is equals to 0, and dy by dt as t equals to 0 is 0, and we will solve this equation by making a electronic circuit for it. So these are the initial conditions. Okay, so how to solve this equation? So the first step is take the highest order term, that is d square y by dt square here, to the LHS, and all the other terms to the other side of the equation. So that's we have done here. We took the highest order term to the LHS and all the other terms in the RHS. Now how to implement this circuit with our this equation with our electronic circuit, that we will see. So this is the circuit I have made to solve this differential equation. Now what is happening here, that is very important to understand. So basically let me name these circuits first. So let us call this component as first, this component as second, and this one as third, and this one as fourth. So that I can give you some instruction and you can follow. So see the first one. So what is happening in the first one is, here you have an resistance and here you have capacitance, and the input is given as the inverting input terminal. Okay, similarly second circuit is also the same. So these two are basically your integrators. Okay, integrators, what they do is they integrate the input signal, and at the output you will get the integrated signal. And as the input is given as the inverting terminal, so the output will be inverted by 180-degree phase shift. That is, here if it is plus, here it will become minus. So at the input you gave y double dot, that is d square y by dt square, so that will get integrated, and at the output you will get minus y dot. Now it will again get integrated by the second circuit, as the second circuit is also an integrator, so the sign will be again inverted, so you will get y at this output. Now what you have done is you have given this minus y dot to this amplifier here. Now what kind of amplifier it is? So this op amp is basically an inverting amplifier, as the input is given in the inverting terminal and the non-inverting terminal is grounded. So the gain of this amplifier is basically given by this feedback resistance, that is 1 omega ohm, divided by this input resistance, that is 1 mega ohm. So 1 divided by 1 is 1, so the gain of this op amp is 1. So when you, and it will also invert the signal, so when you give it the minus y dot, what it will provide you at the output is y. So at the output you will get y. And now comes the fourth unit of this circuit. So basically this is provided with three inputs, that is, the first one is y, the second The second one is y dot, so this is basically y dot. This is not an integrator. Okay, so this is basically this just changed the sign, as the gain is 1, so it basically gave you y dot. So the fourth unit is provided with three inputs, that is y and y dot and minus of ct. So and the fourth unit is basically an inverting summing amplifier, so this will sum these three, first, second, three, and there will also be and scaling factor, that is the gain of the inverting amplifier. Okay, so what you will get at the terminal B is basically R3 divided by R1 times Y, that is the first input, plus of the second input is given as R3 divided by R2 times Y dot, and plus R3 divided by R3, that is 1. So and then you have minus of CT, minus of CT. So all of this inverted, that is minus sign in front of it. So this is what you will get at the output. Now you see what we have done is we have connected this B to the A. So what this is doing is this is enforcing the equality. This is forcing the equality, that is this is making the condition B is equals to A, that is at the A you have y double dot, so basically this is y double dot equals to this thing, and that is what we have to realize. So we have to realize this equation. So as you can see, we have done it already. A can be given as R3 by R2 and B can be given as R3 divided by R1. So basically we have made the equation, we have also forced the equality. Now what will happen, if you run this circuit, you will get the output at the Y, and that output you can see at the oscilloscope. So we have basically solved the problem. So that's all for today. I hope you have got the lecture. You have understood everything. If you have any doubts, you can ask in the comment section. Don't forget to like, share and subscribe the channel. Thank you very much.